Only in the case of carbon number 1, the OH group is present below the plane in the case of alpha glucose and above the plane in the case of beta glucose, right? So beta glucose molecules, by condensation reaction, they join together in a straight line in an unbranched chain, right? Giving rise to what? The cellulose molecule. Okay, so we'll see how this happens, how the reaction occurs. So to begin with this, I'm going to draw 4 beta glucose or 3 beta glucose molecules to begin with, right? One and two. And 3, right? So in the case of the beta glucose, what happens? At carbon number 1, the OH is above the plane. I'm not drawing other atoms. I'm just writing the ones that are related to the reaction, right? So here, carbon number 1 above the plane OH. But at carbon number 4, it's the normal, below the plane, right? Here also at carbon number 4, it's normal, below the plane. Now the problem is 1, right? Now the problem is, this is carbon number 4, this is carbon number 4, right? The problem is that the OH molecules are not adjacent, right? They're not in front of each other. Now because they're not adjacent, they cannot react easily. For the reaction to take place, that means somehow we have to make such arrangements that this OH or this OH comes in front of the other OH. So what happens? This molecule flips at 180 degrees. When it flips, what happens now? I'm just flipping it, just like this. This oxygen moves here because it's flipping, right? The OH goes up here, the H comes down, right? And in this case, this one also obviously, the OH comes down and H comes here. So this one has rotated at a 180 degree for the reaction to take place. Now, because this molecule, this did not rotate, but this molecule rotated at 180 degrees, and what happened? The oxygen that was initially here, that has now moved down, right? And because of that, the position of OH also changed, right? This is a beta glucose molecule, this is a beta glucose, and this is a beta glucose still. But this beta glucose has just flipped itself for the reaction to take place so that the OH groups can become adjacent to each other. Now what happens? Water molecule is eliminated, as you all already know, and oxygen forms a bridge and the bond is formed. Now, this did not rotate, this did rotate. This one also does not need to rotate now because the OH are already adjacent. Because of the rotation of this molecule, the OH have already become adjacent, right? So, here also, water molecule will be given off and the bond will be formed here. One bond is formed above the plane, the other bond is formed below the plane. Now, the next molecule that comes after this, that will have to flip again now, because if I draw it here, so in this case, the OH will be down, right? So this one will have to flip again. So in the case of the cellulose molecule, while the linkage is taking place, while the condensation reaction is taking place, what happens? Every second molecule flips at 180 degrees, right? The first did not flip, the second one did. Then the third will not flip, the next one will. So one after the other, or every second molecule rotates at 180 degrees for the OH groups to come adjacent or in front of each other for the reaction to take place. So when the entire linkage is done, it looks something like this. I'll make tiny molecules. So when the linkage is done, It looks something like this. See? So, one bond is formed here, the other one here, the next one here. So this is what the molecule looks like. One bond above the plane, the other bond below the plane, then the other bond above the plane. So this one would flip and this one would flip. So every second molecule flips when the oxygen is facing downwards. That means that molecule has flipped, right? Changed its position, rotated at 180 degrees for the bond formation to take place. So this is how the cellulose molecule is formed. The cellulose molecule does not exist in the form of a straight chain just like this in the cell walls. It actually forms fibers. Now, how does it form fibers? Initially, first of all, hundreds of molecules join together in straight chains, giving rise to cellulose. Then, 60 to 70 cellulose molecules, they come together, they bond together, and they give rise to microfibrils, right? How do microfibrils stay attached? With hydrogen bonding. There is extensive hydrogen, there is extensive oxygen present. So because of hydrogen bonding, the hydrogen bonding actually, and we'll see in a while what hydrogen bonding is, how does it happen. So because of the hydrogen bonding, the microfibrils are held in their position. Then what happens? The microfibrils, they come together, numerous microfibrils, and they give rise to what? Fibers, right? So many monomers joining together, hundreds of monomers joining together in this reaction by condensation, giving rise to what? Cellulose molecules. Then 60 to 70 cellulose molecules coming together, giving rise to what? Microfibrils. Then microfibrils assembling together, joining together, forming tough fiber structures called fibers. Then these fibers, cellulose fibers, then make up the cell wall. How do they make up the cell wall? By layering, right? There are layers, a primary layer of cellulose fibers, then there's a secondary layer of cellulose fibers, then a tertiary layer of cellulose fibers. So by layering, they strengthen the cell wall, right? The layering increases the tensile strength, and that is how they're able to make the cell wall thick enough and to make it rigid enough for the cell to not burst when it becomes turgid or when it becomes filled with water, right? So this was all about cellulose, right? And the only thing that's left right now is that we have to study how are hydrogen bonds formed and what are polar molecules or what are dipoles. I hope you're all clear on this, right? Okay, the only thing that is left for today is how are dipoles formed or how are dipoles and hydrogen bonds linked, right? So I hope that you have already heard of the word dipoles or a polar molecule. Have you heard of a polar molecule? What's a polar molecule? And what are hydrogen bonds? That's what we discussed. Okay, I'll give you an example of water, right? You already know that water's formula is H2O, right? That means two hydrogen and one oxygen molecule, they're forming a bond, right? Looking something like this: oxygen, hydrogen, hydrogen. Now, this is a covalent bond, we all know, a shared pair of electrons is there. In the case of hydrogen, in the nucleus of hydrogen, you have only one proton, right? That means this one contains one positive charge, one positive charge. In the case of oxygen, you have 6 protons, right? That means you have 8 positive charges, 8 protons in the case of oxygen, right? Now, this shared pair of electrons will be attracted definitely more by 8 protons as compared to 1 proton. So when you take X-ray images, right, what you see is that the shared pair of electron has moved towards the oxygen atom, right? Now, because the electron shared, it's still a shared pair. It cannot take it all away, but it attracts it a little more than hydrogen can. Now, because of that, oxygen atom gets a partial negative charge, not a complete negative, but this sign indicates what? Partial. It gets a partial negative charge. It seems like it has gained those electrons, and because of gaining electrons it gets a partial negative charge, and it seems like that hydrogen has lost the electrons, and because of that it gets what? A partial positive charge. Such a molecule that has two different poles in it is termed as a dipole or a polar molecule, because it has poles formed in it, right? So I hope the dipole part is clear. Whenever there is unequal sharing of electron pair in a covalent molecule, what happens? Because of that unequal sharing, the electrons tend to move towards the more electronegative atom, the one that has more protons in it, the one that can attract it more, right? It does not completely get transferred to that atom, it just moves towards that atom a little more than the other one, right? Seems like that atom gets what? A partial negative charge, and the other one gets a partial positive charge. Because of that, there are two poles created within the same atom, or sorry, within the same molecule, right? These poles make this molecule a polar molecule or a dipole. Now, moving on to hydrogen bonds. Dipoles that have hydrogen in them, they show or they exhibit the property of hydrogen bonding. Now, what is hydrogen bonding? See, a water molecule, and I'm drawing more now. Partial positive, partial negative, then partial negative, partial positive, right? Now, what is going to happen? This partial positive molecule, sorry, atom, is going to attract the partial negative atom of the neighboring molecule, right? Like this. Similarly, this one is going to attract this one. So, this one is going to attract another one. This is going to attract another one. Similarly, this will form a hydrogen bond. So, this bond, this weak force of attraction, that is an intermolecular attraction, that is formed between a partially negative hydrogen atom and any other, partial positive hydrogen atom and any other partial negative atom, is termed as a hydrogen bond. This one is termed as a hydrogen bond. Remember, hydrogen bond is not required to make up the water molecule. Water molecule is formed by the covalent bond. The intramolecular force is the covalent bond, right? But the intermolecular force, the force between two molecules, that is what hydrogen bonding, that is keeping them together. Because of extensive hydrogen bonding, water has such different properties than any other molecule that is found. Water has a very high specific heat capacity because no doubt that hydrogen bonds are weak, but they're so extensive that so much heat is required for the molecules to break them, and until and unless the hydrogen bonds are broken, the water molecule will not change into vapors. For them to change into vapors and for them to evaporate, they have to get rid of the hydrogen bonds. So although hydrogen bonding is weak, but because it is extensive, it strengthens the molecule. So wherever we use the term that hydrogen bonding is strengthening the molecule, just like in cellulose, I said that the fibers or the microfibrils, they're held together by hydrogen bonding. Hydrogen bond is a weak bond, but the number of bonds, as they increase the tensile strength of the molecule, right? So I hope the dipole is clear and I hope the hydrogen bond is clear. So till today, we have covered carbohydrates, we have done monosaccharides, we have done disaccharides, and we have done polysaccharides. I am not starting the chapter, the topic lipids, because we'll not be continuing with our lectures in the next week, right? So if we continue after next week, inshallah, we'll be beginning with lipids, right? That's all for today. Please do study like the week that you have off. Please do try and read up the entire topic of carbohydrates, and then we'll continue with lipids, inshallah, whenever the classes continue again. See you next time. Allah Hafiz.